Back when iOS 8 came out, Apple introduced a feature called Mac Randomization. What the feature was meant to do was to reduce the ability for people to make use of your MAC address on your phone as a mechanism of tracking. The basics of what were going on was that your phone, constantly sending out probe request frames looking for wireless networks, was using its integrated or hard-coded MAC address, and it creates capacities for tracking. You'll be able to tell where users are based on their MAC address, and if you have a sufficiently large number of distributed, say, Wi-Fi collectors, you can actually follow a user around as they travel about, say, a shopping center or even a city. And I read one article briefly that talked about how some marketing company had placed garbage cans all around the city that also had integrated Wi-Fi collectors on them and were being used to track people's movements and whereabouts. Now, there's obviously some really cool marketing opportunities that are available for that, where you can see that if a person's in location A, they're able to go in and offer you some targeted product advertising. But from a privacy perspective, you can definitely gather more information about people than they may otherwise want to share. So Apple, in an effort to protect people's privacy, went and changed that feature so that when your phone is sending out these probe request frames, it uses a randomized MAC address. Now, there were some criticisms over the way that it was originally deployed, where location services had to be turned off, and there were a couple other factors that maybe weren't as feature-rich as privacy advocates would want. And they've definitely made some changes to it in iOS 9, where they say that not only are they using randomized MAC addresses for sending out searches for preferred networks, but they've also are using randomized MAC addresses when they're doing probe requests looking for, say, location-related information. But the documentation is sparse, to say the least. So I want to understand it better. I want to know exactly in an iOS 9 device what these things are doing. How are the MAC addresses being randomized? How is it different than it is in iOS 8? What capacity is there for me to still be able to, say, learn something about you based on these randomized MAC addresses? Or is there any capacity at all? So I had originally done some research on it and tried to do some test captures in my office. The problem is that my office is a multi-tenant office building, so the ability for me to tell who's who and what's what when MAC addresses are randomized is largely non-existent. So what I wanted to do is I wanted to go in and basically go get myself a radio-free environment. I'm going to go set up in the middle of a field and take and watch what my phone does, run an iOS 9, and see what happens when there's no other radio sources around to confuse things, so that I can get a really good picture and understanding of exactly what this device is doing. This whole MAC randomization thing was first introduced in iOS 8, and it exists in iOS 9, and they've extended it and sort of expanded its capabilities. And basic idea was to be able to limit the ability for people to be able to track you by your MAC address. So one of the other things that's really important to remember on this is that all of this MAC randomization stuff has to deal with you not being connected to a wireless access point. As soon as you connect to a wireless access point, you use your real MAC address. So from a tracking perspective, if somebody could get you to simply associate with different access points as you move through, say, a shopping mall or move around town, then they can track you because you'll be using your real MAC address. But as long as your device is sitting in your pocket, sitting in the console of your car, whatever, and it's not associated with wireless LAN, then it's going to be using randomized MAC addresses, and it will be very difficult for somebody to be able to track you because the device is changing its MAC address on a regular basis. Apple breaks down the scans that its device sends into 4 different categories. They refer to them as Pno scans, which stands for Preferred Network Offload. There's an ePNO scan, which is an enhanced Preferred Network Offload scan. There's a location scan, and then the 4th type of scan is an auto join scan. In my testing, all 4 types of scans were identical. I was not able to determine that this probe request frame sent by the device versus this probe request frame or this probe request frame was one versus the other. They're all sent as probe request frames, and for the most part, they're all sent to the broadcast SSID. The one exception to that I did notice was if you have a profile on your phone that is configured to connect to a wireless access point that is using a hidden SSID, then your device will send probe request frames for that specific SSID, which is terrible. Because that means that if I connect to my buddy's wireless network and he uses a hidden SSID, my device is going to be sending out probe request frames looking for that SSID everywhere I go, which is kind of what it's been doing for a long time anyway, but we simply don't want that. That creates the tracking opportunity now, but not with MAC addresses. Now the tracking opportunity is with your SSID. If you're connected to a hidden SSID and I see you send a probe request frame for Dojo test 44 as an SSID using a randomized MAC address, and then 5 minutes later you send another probe request frame looking for that same SSID using a completely different MAC address, I can say with a reasonable degree of assurance that that's the same device. So therefore I'm tracking you. Now, if there were 30 people in the same environment, all who had been connected to this hidden SSID, well then yeah, that changes things. But me walking around a shopping mall with my phone in my pocket, having been probably the only person in the mall who's been connected to the hidden SSID at my house, I'm the only one who's sending probe request frames looking for that particular network. So you can absolutely track me based upon my probe request frames for specific SSIDs. That's not an across-the-board truism, but it's certainly an opportunity for somebody who wanted to go in and figure out a way to get around this. So stop using hidden SSIDs. I know it looks like it secures your network more, but it doesn't. It's better to just broadcast your SSID and use good authentication and encryption. One of the things that I had to figure out when I was going and looking at all those stuff was what do they mean by preferred network offload? Really what preferred network offload is about is all about power saving. When your device, you lock the screen or the device goes to sleep, iOS sends a preferred network offload list, a list of networks for which you have a profile, to the firmware that's on the NIC for the wireless adapter, and says, look dude, I'm crashing out. So while I'm sleeping, if you would keep an eye out for these networks, and if you see one of them, go ahead and connect to it. That's what a network offload is really all about. And preferred network offload scans are specifically for that purpose. You are A, not connected to a network, and B, would like to be. So you have a list of networks that you know how to connect to, and so you're going to send probe request frames into the network, basically looking to see if any of those particular networks are around, and if so, you'll connect to one. Enhanced preferred network offload scans are used by location services to be able to figure out where you are, so that it can do things like give you reminders based on your location. Location scans are used by different apps, by your camera, by the operating system itself in order to send out probe request frames in order to be able to figure out where you are. The thing about location scans is that they're sent even if you're associated to a wireless network, because they look a little bit confusing. It's like, well, an ePNO scan helps me determine where I am, but it's used by location services, but then we also have location scans which are used by location services, and so like what's the difference? And from every little bit of reading and research that I've been able to do, the difference is that an ePNO scan is used when you're not associated to a wireless LAN, and a location scan is going to be used even if you are associated to a wireless LAN. And so these scans are specifically designed to be able to help determine, say, where you are in traffic, or to any other service or app that's on your device that needs to be able to know where you are. It leverages this whole idea of crowdsourcing or any app that's used in location services to be able to determine what your location is. And then last, there was auto join scans. Auto join scans are when you're going to connect to either an 802.11u/hotspot 2.0/passpoint network. So what did my test reveal? First thing that it revealed is none of the stuff matters as far as randomization if you're actually associated to a wireless access point. If you're associated to a wireless access point, you're using your real MAC address. Okay? You're not using MAC randomization. Second thing is that it doesn't matter which frequency you're using. If your device is using both the 2.4 and 5 gigahertz frequencies or just one or the other, it's using the same randomized MAC address on both frequencies. Third thing that I saw was I had no capacity in the packet captures that I did to really be able to determine, just looking at the captures, whether this particular probe was a Pno scan, an ePNO scan, a location scan, an auto join scan. There was nothing different in the way that the probe requests look. For the most part, all of the probe request frames are sent to the broadcast SSID, or to the null SSID. The exception to that, of course, was when the device was trying to connect to a hidden SSID, in which case it sent out the name of the network that it was looking for. The fourth thing that I noticed is that as soon as you lock the screen or the device goes to sleep, it generates a new MAC address. The MAC address also changes on a periodic basis. Now, I didn't really get into trying to figure out what the timeline was. I wasn't able to find any documentation from Apple on what the timeline was. But if your device stays locked, it continues to change the MAC address over time. It doesn't just selectively, or choose a randomly selected MAC address and then stick with it. It'll create that random MAC address, and then it will go and change it again. And then after a certain number of seconds, it changes it to a new one. The other thing that I noticed was that if you pick the device up after it's been sitting for a little while, it generates a new MAC address. So locking it generates a new MAC address, and then if you come by later on and pick it up, that generates a new MAC address. And picking it up causes probe request frames to be sent. Now, that has to have something to do with location services or some kind of location scan. So I could sort of infer that that was a location scan because I'm sitting there able to pick the device up. But if I was just seeing the packet captures, I wouldn't be able to make that determination. Then the fourth thing that I was able to determine is that if you start interacting with the device, okay, so if my device is locked, when I lock the screen, he just generated a new MAC address. But if I were to let that sit for a bit and then I pick it up, it's going to generate a new MAC address. When I unlock the device and I begin to interact with it, if he's not associated with a wireless LAN, he starts to send a very large number of probe request frames, and he continues to do so while I'm interacting with the device. What I'm taking from that is that he says, oh, this person's using the device, we need to see if we can get a network and get connected to it. And so the frequency of probe request frames goes up dramatically when the person is interacting with the device. And the device becomes idle again. When I lock the screen, then he's going to go in, he'll generate a new MAC address, and then he'll start his more lazy sending of probe request frames looking for networks that he can connect to. I kind of thought about, well, what could I learn from that? And if you're seeing one particular MAC address send out a very large number of probe request frames, you could, by implication, say that person is using their device right now. So imagine you could match this up with, say, video surveillance. And you've got 5 people, and one of them is you can visually see is doing something with their device. And in your captures over the radio network, you can see a very large number of probe request frames coming from one MAC address. You could, by implication, say that those frames are from that one person who's interacting with their device, whereas the other 4 people who are sitting around not interacting with their devices, they're the other MAC addresses. I don't know which ones. Most of what I've figured out here is either through the few different posts that I've seen on the internet or stuff that I've been able to go in and manually figure out for myself just doing captures. But I have to kind of give a nod to the whole idea of MAC randomization, because when I tried to do this analysis from my office, it simply wasn't working. Because there were so many devices coming in and coming out, I couldn't tell which one was my device. That made it very difficult, which is kind of the point. If you sit back and think about it, I had to go sit in the middle of a field with no other sources of radio energy around in order for me to be able to see what this one lone solo device was doing. So the fact that I had to go do that in order to be able to figure out what the device was up to is kind of a testimony to MAC randomization. I don't think MAC randomization is perfect. I still think that there's going to be opportunities for people to do some limited tracking, but only in certain circumstances. If you're not connecting to hidden SSIDs on a regular basis and you're not associated with an actual wireless LAN, the ability to track you is actually pretty well reduced when it comes to MAC addresses. So that's where I'm going to end it. And I appreciate you watching. Hopefully you got something out of this. If you have any questions or any other things that you're thinking about, or if you know something else that you want to add to it, please put it in the comments below. Everybody else will benefit from it, and that'll be awesome. So again, thank you, and I will see you guys next time.